In this discussion video, we'll do some practice limit questions involving using the conjugate. So I want to look at worksheet 2, problems 7, part G and M, which I have copied here. And I want to begin by giving you just 1 minute to think about how you would begin G. 4, 3, 2, 1. Pause the video. Pause it for 1 minute to think about how you'd begin G. It's probably not going to be enough time to finish the problem, so I don't want you to stress about that. Just think about what the key ideas are in terms of beginning. Alrighty, so hopefully you paused it and tried it for about a minute. Let's talk about it together now. So remember, the first step when doing a limit like this algebraically is to plug in. So if I plug in 16, we're going to get 2 minus root 16 minus 12 is 4. So root 4 on the top, and then 16 minus 16 on the bottom. So root 4 is 2. So the numerator is 0, and the denominator is 0. So we have this indeterminate form. And we know that to handle those, we have to simplify. We are going to have to simplify this. The issue is the square root is kind of in the way. So there's this technique from algebra that I want to recall. And that is called multiplying by the conjugate. In fact, let me give myself some more room here. So we are going to multiply by what is called the conjugate. Okay, so I'm going to set it up and I'll talk about why it works after. The limit as x approaches 16 of 2 minus square root of x minus 12 over x minus 16. So when I multiply by the conjugate, what I'm going to do is multiply the top and the bottom of this fraction by what looks like this square root term on the numerator, but just change the sign in front of the square root. So I'll get 2 plus root x minus 12, and whatever I multiply by on the top, I got to multiply by on the bottom. So 2 plus root x minus 12 on the bottom as well. Okay, so why is this going to be helpful? It actually has to do with the structure of multiplying something by its conjugate. And so what I have first on the top is something minus that square root, a minus b. And then I'm multiplying it by a plus b. But you might notice, wait, that's just difference of squares once it's factored. If I multiply this out and FOIL and distribute, this is a squared minus b squared. So if we do that for our limit, we get the limit as x approaches 16. And if I distribute out this numerator, I'm going to first get my a squared, which is going to be 2 squared, and then minus my b squared, which is going to be the square root of x minus 12 squared. And notice that is going to nicely get rid of that square root on the top for me. And on the bottom, I'm going to keep it as x minus 16 times the 2 plus root x minus 12. I multiplied by the conjugate specifically, so the top became nicer. On the bottom, the conjugate isn't really going to help if I distribute it. So it's actually better to keep it like this, because it'll be easier to see if something cancels later. All right, so now if I work out what this numerator is, 2 squared is 4, and then I'll get minus a bunch of stuff, so I should keep that in parentheses. When I square this square root term, I'll be left with x minus 12. And simplifying that, once I distribute that negative sign, we will get 16 minus x. All right, so this equals the limit as x approaches 16. I'm going to have 16 minus x on the top. I have almost that on the bottom. So I'm going to factor a negative out of the term on the top. That'll change it to x minus 16 to match what I have on the bottom. X minus 16 times 2 plus root x minus 12. Remember what I said about things might cancel later? That's happening now. So they cancel, and after they cancel, now let's try to plug in. I'm left with negative 1 on the top. And on the bottom, I'll get 2 plus square root of 16 minus 12, so that's root 4. So this equals negative 1 over 4. And that is our answer. So that is multiplication by the conjugate. We actually haven't done a multiplying by the conjugate example in lecture yet. We will in our next day of lecture, but it's actually a technique that I think that we were ready to handle once we just reviewed that fact from algebra. All right, so let's look at part M now. So for part M, I want to first give you an opportunity to try it. Pause your video for 3 minutes to tackle this question. 4, 3, 2, 1, pause it and try this one for 3 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. Totally fine if you didn't get all the way through, but hopefully you were able to think about what some of the key ideas are and how you'd begin and make some progress. And if you have questions as you work through some of these, that is totally natural and actually a good thing. But I want you to bring those questions and use our resources for help. So bring those to office hours or to tutoring, and we're happy to help. So first, let's plug in. Doing that, we'll get 4 cubed minus 64 on the top. On the bottom, I'll get root 4 minus 2. So the top is going to be 0, the bottom is going to be 0. Indeterminate form, so we simplify. So we are going to simplify. So hopefully we're getting comfortable with plugging in as a first step, and then depending on my form, recognizing what technique to use, in this case simplify. All right, so we have the limit as x approaches 4 of x cubed minus 64, root x minus 2. Let's try this conjugate thing again. So I'm going to multiply top and bottom by square root of x plus 2. I know for the previous example, I said change the sign in front of the square root term. It actually doesn't matter whether I change the sign in front of the square root term or the sign in front of the other term. In this case, I think it just looks a little nicer to change the sign in front of the other term, so I'm going to do that. All right, so now when I do this multiplication, I'm going to multiply out the denominator. So when I do that distribution, I'm going to get my first thing squared minus my second thing squared. Oh, whoops. Second thing is 2 squared. That's what I get when I distribute out. Okay, and then on the top, I'm not going to distribute out. I'm going to keep it as x cubed minus 64 times root x plus 2. Because the conjugate is specifically helpful. It's specifically going to be helpful for the denominator, to get rid of that root in the denominator. It's not going to be as helpful for the numerator. So it's helpful to keep the numerator not distributed out so I can see cancellations later. All right, so we get the limit as x approaches 4. And now in the denominator, I'm going to get x minus 4. So I don't quite see x minus 4 in the numerator, but I don't panic because I recognize something. X cubed minus 64, that is a difference of cubes. And that factors, so that is x cubed minus 4 cubed. So if I use difference of cubes, it factors as x minus 4 times x squared plus 4x plus 4 squared. And then I still have that root x plus 2 on the top. Now I get that cancellation I was hoping to see, and then I can plug in. So if I plug in 4, let's see, I'll get 4 squared, which is 16, plus 4 times 4, which is 16, plus, I already did 4 squared, that's another 16. All right, and then plugging it in the next parentheses, I get root 4 plus 2. All right, so these 16s added up give me 48. 2 plus 2 is 4. And then 48 times 4, that is 192. And that's my answer.